A baptismal pool would fall under Section 680.22 of the National Electrical Code, also known as the NEC. This section pertains to swimming pools, fountains, and similar installations. No, an e-stop is not required within 5 feet of a baptismal pool according to the NEC. However, local codes or regulations may have additional requirements, so it is vital to check with your local authority having jurisdiction to determine if one is needed. The circuit supplying the baptismal pool should be rated for the maximum load, which is likely to be 50 or 60 amps for a heated pool. The baptismal pool should be protected by a ground fault circuit interrupter, also known as a GFCI, with a rating of at least 30 mA. This GFCI can be located on the circuit breaker or in a separate enclosure. During the inspection, here are some additional items to verify. Firstly, verify the pool size, depth, and materials used in construction. Secondly, check the electrical equipment, including the heater, pumps, and lighting, for proper installation and grounding. Thirdly, inspect the bonding system, including the bonding grid and any bonding conductors. Fourthly, ensure that all electrical work complies with the applicable codes and regulations. When looking at Section 680.22 of the NEC, it is crucial to consider all its subsections to ensure complete compliance. Subsection A generally covers the area extending 10 feet horizontally from the inside walls of the pool. This area is subject to specific rules regarding receptacle placement, lighting, and wiring methods. Within this zone, all receptacles must be GFCI protected. Lighting fixtures must meet certain height requirements above the maximum water level or be GFCI protected. Wiring methods must be suitable for wet locations, typically requiring the use of conduit or direct burial cable. Subsection B addresses specific requirements for luminaires, lighting outlets, and ceiling fans. It stipulates minimum mounting heights and clearance distances from the water's surface. For example, luminaires installed less than 12 feet above the water level often require GFCI protection. Ceiling fans must be at least 12 feet above the maximum water level. Subsection C delves into the rules for switches, receptacles, and other electrical equipment near the pool. Receptacles must be located at least 6 feet away from the inside walls of the pool unless they are GFCI protected and used for pool-related equipment. Switches must be at least 5 feet away from the inside walls, or they must be GFCI protected and clearly labeled for pool equipment use. It's important to consider the requirements for underwater lighting. Section 680.23 covers this, and it mandates that underwater luminaires operate at a low voltage, typically 12 volts alternating current. These luminaires must be specifically approved for underwater use and installed in accordance with the manufacturer's instructions. Transformers supplying these low-voltage luminaires must be located at a safe distance from the pool, usually at least 10 feet away. Furthermore, the metal parts of underwater lighting systems must be properly bonded to the pool's bonding grid to minimize the risk of electric shock. For pool heaters, Section 680.25 provides guidance. Pool heaters must be installed in accordance with their listing and labeling. They should be readily accessible for maintenance and repair. The wiring to the pool heater must be sized appropriately for the heater's load, and the heater must be protected by a disconnecting means located within sight of the heater. GFCI protection is generally required for pool heaters, especially those installed near the pool. Bonding is a critical safety measure for all swimming pools. Section 680.26 outlines the requirements for bonding metal parts of the pool structure and equipment. The purpose of bonding is to create an equipotential plane around the pool, minimizing voltage gradients and reducing the risk of electric shock. Bonding typically involves connecting all metal parts, such as the pool reinforcing steel, metal fittings, pump housings, and metal conduits, to a common bonding grid. This grid is then connected to the electrical grounding system. The bonding conductors must be sized appropriately, typically number 8 American wire gauge copper or larger. GFCI protection is a key component of electrical safety for swimming pools. A GFCI is a device that detects ground faults, which occur when electricity leaks from its intended path to ground. GFCIs are designed to trip quickly, interrupting the flow of electricity and preventing electric shock. Section 680 requires GFCI protection for various circuits and equipment associated with swimming pools, including receptacles, lighting fixtures, and pool heaters. The GFCI protection can be provided by GFCI circuit breakers or GFCI receptacles. Regular testing of GFCIs is essential to ensure their proper operation. In addition to the specific requirements of Article 680, it's also important to comply with other relevant sections of the NEC, such as those pertaining to wiring methods, grounding, and overcurrent protection. Proper wiring methods are essential to ensure the safety and reliability of the electrical system. Wiring methods must be suitable for the environment, including wet locations and corrosive environments. Grounding is another critical safety measure that helps to protect against electric shock. The grounding system must be properly installed and maintained to provide a low impedance path for fault current to return to the source. Overcurrent protection, such as circuit breakers and fuses, is designed to protect the electrical system from overloads and short circuits. Overcurrent protection devices must be sized appropriately for the circuits they protect. Here's a detailed breakdown of GFCI requirements in Article 680. Firstly, all 125-volt, 15 and 20 amp receptacles located within 20 feet of the inside walls of the pool must be GFCI protected. This includes receptacles used for pool equipment, as well as general-purpose receptacles. Secondly, lighting fixtures installed within 10 feet of the inside walls of the pool must be GFCI protected. This includes both underwater lighting and above-ground lighting. Thirdly, pool pump motors must be GFCI protected, regardless of their voltage or horsepower rating. The GFCI protection can be provided by a GFCI circuit breaker or a GFCI receptacle. Fourthly, electric pool heaters must be GFCI protected. This requirement applies to both newer and existing pool heaters. Fifthly, any electrical equipment used in or around the pool, such as stereos, televisions, and power tools, must be GFCI protected. This is to prevent electric shock in case of a ground fault. The NEC also addresses the requirements for equipotential bonding in swimming pools. The purpose of equipotential bonding is to create a common electrical potential throughout the pool area, minimizing the risk of electric shock. Firstly, all metal parts of the pool structure, including the reinforcing steel, metal fittings, and metal conduits, must be bonded together. This can be achieved by connecting the metal parts to a common bonding grid using copper bonding conductors. Secondly, all metal equipment associated with the pool, such as the pump motor, filter, heater, and lighting fixtures, must be bonded to the bonding grid. This ensures that all metal parts are at the same electrical potential. Thirdly, the bonding grid must be connected to the electrical grounding system. This provides a path for fault current to return to the source, tripping the circuit breaker and energizing the circuit. Fourthly, the bonding conductors must be sized appropriately, typically number 8 American wire gauge copper or larger. Fifthly, the bonding connections must be made using approved connectors and methods. The NEC also includes specific requirements for wiring methods used in swimming pool areas. Firstly, wiring must be installed in conduit or other approved raceway. This provides physical protection for the wiring and helps to prevent damage. Secondly, wiring must be suitable for wet locations. This means that the wiring must be resistant to moisture and corrosion. Thirdly, wiring must be installed at a safe distance from the pool water. This helps to prevent electric shock in case of a fault. Fourthly, wiring must be properly supported and secured. This prevents the wiring from sagging or becoming damaged. Fifthly, wiring must be installed in accordance with the manufacturer's instructions. The NEC also addresses the requirements for overcurrent protection in swimming pool areas. Firstly, circuits must be protected by circuit breakers or fuses. This protects the wiring and equipment from overloads and short circuits. Secondly, circuit breakers and fuses must be sized appropriately for the circuits they protect. This ensures that the overcurrent protection devices will trip in the event of an overload or short circuit. Thirdly, circuit breakers and fuses must be readily accessible. This allows for quick and easy restoration of power after a fault. Fourthly, circuit breakers and fuses must be labeled to indicate the circuits they protect. This helps to prevent confusion and ensures that the correct circuit is energized in the event of a fault. Fifthly, circuit breakers and fuses must be installed in accordance with the manufacturer's instructions. Remember to consult local codes and regulations, as they may have additional requirements beyond the NEC. Always prioritize safety when working with electricity, especially in and around swimming pools. When performing an inspection, pay close attention to the following details to ensure compliance with Article 680 of the NEC. Examine the GFCI protection for all required circuits and equipment. Verify that the GFCIs are properly installed and tested. Check the equipotential bonding system to ensure that all metal parts are properly bonded together. Inspect the wiring methods to ensure that they are suitable for wet locations and installed at a safe distance from the pool water. Verify that the overcurrent protection devices are properly sized and labeled. Look for any signs of damage or deterioration to the electrical equipment. Confirm that all electrical work has been performed by qualified personnel. Ensure that all electrical work complies with the applicable codes and regulations. Document any deficiencies or violations and take corrective action. Here is some more specific information about the bonding requirements for a baptismal pool. The NEC requires that all metal parts of the pool structure, including the reinforcing steel, metal fittings, and metal conduits, be bonded together. This bonding is typically achieved by connecting the metal parts to a common bonding grid using copper bonding conductors. The bonding grid must then be connected to the electrical grounding system. The purpose of this bonding is to create an equipotential plane around the pool, minimizing voltage gradients and reducing the risk of electric shock. The NEC specifies the minimum size for the bonding conductors, which is typically number 8 American wire gauge copper or larger. The bonding connections must be made using approved connectors and methods. When inspecting the bonding system, look for the following. Firstly, ensure that all metal parts are properly connected to the bonding grid. Secondly, verify that the bonding conductors are the correct size and type. Thirdly, check the bonding connections to ensure that they are tight and secure. Fourthly, ensure that the bonding grid is properly connected to the electrical grounding system. If you find any deficiencies in the bonding system, take corrective action to ensure that the pool is properly bonded. Here are some additional points to consider regarding GFCI protection for baptismal pools. The NEC requires GFCI protection for all 125-volt, 15 and 20 amp receptacles located within 20 feet of the inside walls of the pool. This includes receptacles used for pool equipment, as well as general-purpose receptacles. The NEC also requires GFCI protection for lighting fixtures installed within 10 feet of the inside walls of the pool. This includes both underwater lighting and above-ground lighting. Pool pump motors must be GFCI protected, regardless of their voltage or horsepower rating. Electric pool heaters must also be GFCI protected. The GFCI protection can be provided by a GFCI circuit breaker or a GFCI receptacle. When inspecting the GFCI protection, test the GFCIs to ensure that they are functioning properly. Look for any signs of damage or deterioration to the GFCIs. Verify that the GFCIs are properly labeled. If you find any deficiencies in the GFCI protection, take corrective action to ensure that the pool is properly protected. In summary, baptismal pools are subject to specific electrical codes and regulations. It's crucial to understand and comply with these requirements to ensure the safety of the pool users. Article 680 of the NEC provides detailed guidance on the electrical safety requirements for swimming pools, including baptismal pools. When inspecting a baptismal pool, pay close attention to the bonding system, GFCI protection, wiring methods, and overcurrent protection. Consult with qualified electrical professionals to ensure that the pool is properly installed and maintained. Regular inspections and maintenance are essential to ensure the ongoing safety of the pool. Remember to always prioritize safety when working with electricity, especially in and around swimming pools. Always to energize circuits before working on them. Use appropriate personal protective equipment such as rubber gloves and safety glasses. Follow safe work practices. Seek assistance from qualified electrical professionals when needed.